Now, the other thing we need to know how to reduce is a fraction that has variables in it. So what about x to the fourth over x to the second? How do we reduce that? Or how do we divide that? Is another way to think of it, because that fraction bar means divide. What is x to the fourth divided by x to the second? Well, there are two ways to look at it. I'll show you the first way, which is a little bit longer, but I think is easier to make sense of. And I'll show you the shortcut way. So the long way is to break down your variables into their prime factorization. In other words, x to the fourth means x times x times x times x. So I have 4 x's being multiplied. X to the second means x times x. So what I can do from here is take it in pieces. I can divide in pieces, or I can reduce in pieces. I can say that x divided by x is 1, so they cancel out. I can then say that this x divided by this x is 1, so they cancel out. So what I am left with is x times x on top. Now, these x's don't entirely disappear that I canceled out over here. What happened was they turned into 1s, because x divided by x is the same as 1, or 1 over 1. 3 divided by 3 is 1, or in other words, 1 over 1, because 1 divided by 1 is 1. So the same concept occurs over here. X divided by x will get you 1 over 1. So these turned into 1s. So on top, I'm left with 1 times 1, which is 1, times x, which is x, times x, which is x squared. And on bottom, I have just 1s. So you don't actually need to put the bottom part of the fraction in. You could just say that x to the fourth divided by x to the second equals x to the second. Now, just to show you that you can do what I did here, because for some of us that may seem a little confusing, why can you split this up into pieces like that? I'm going to show you, this works for any division problem. Okay, you can take, for example, 8 divided by 4, or the fraction 8 fourths. Okay, most of us out there know 8 divided by 4 is 2. Well, I'm going to take 8 and turn it into 2 times 2, which is 4, times 2, which is 8. I'm splitting it into pieces. I'm going to take 4 and split it into 2 times 2. Now, keep in mind, 8 divided by 4 is supposed to equal 2. So if I do what we did over here, and I cross out what they have in common, 2 divided by 2 is 1. 2 divided by 2 is 1. All I'm left with on top is 1 times 1 times 2, which gets me an answer of 2. All I'm left with on bottom is 1 times 1, which gets me an answer of 1. Or in other words, 2 over 1. 2 divided by 1 is 2. So I got the same answer I would have if I did 8 divided by 4 in my head. So let's take a look at the shortcut way. If I had x to the fourth over x to the second, instead of writing out all the x's, the shortcut way is to say top minus bottom. We can say x to the fourth, the top, minus the bottom. So there are 2 x's on bottom, which cancel out 2 of the x's on top. So I am left with x to the second, because 4 minus 2 is 2. Now, what would happen if you had x to the second over x to the third? Now, 2 minus 3 is not going to get you a positive answer. Because remember, it is always, always, always top minus bottom. Top minus bottom. Which equals x to the negative 1. 2 minus 3 is negative 1. Now, I can show you that using the long method that we explained before. X times x over x times x times x. As you can see, these two x's will cancel out these two x's on bottom and be replaced with 1's. So I am left with a 1 on top, because 1 times 1 is 1, and I am left with a single x on bottom, or in other words, x to the first power. Now, if you take a look at Chapter 4, Section 6, we talk about negative exponents. And in that chapter, you will see that 1 over x is actually equal to x to the negative 1. But if you'd like to see an explanation of why or how this could possibly be true, visit the video on Chapter 4, Section 6, Negative Exponents. And I can prove to you that 1 over x does in fact equal x to the negative 1.